Welcome back to AI Talks with Chris and Nita. Today, we're taking a deep dive into hinge loss, which is pretty key to understanding SVM's support vector machine. And these SVMs, they're kind of like the big, strong guys in the machine learning world when it comes to classification tasks.
That's a good way to put it. Yeah. Yeah, they're definitely powerful algorithms.
Yeah.
Hinge loss, that's kind of one of their secrets. It really is a big part of why they work so well.
So how does it actually work? I mean, like, what is hinge loss?
Okay, so imagine you've got all these data points, right?
Okay.
And they belong to different categories. You want to draw a line to separate them.
Like cats and dogs.
Exactly like cats and dogs.
Okay.
Or apples and oranges, or whatever it is you're classifying. Hinge loss is all about making sure that line is drawn in the best way possible.
To give us the most space between the cats and dogs.
Exactly the most separation between those categories.
Okay, so it's not just drawing any old line. It's about finding the line that gives us the most breathing room.
That's right.
Got it.
That extra space, that's what we call the margin. And that margin is important because it helps the SVM generalize better.
Okay, hold on. Generalize better. What does that mean?
It means it can handle new data, better data it hasn't seen before. So let's go back to your cats and dogs.
Okay.
Imagine you train a model to tell them apart. With a large margin, even if you show it a picture of a cat dressed up like a dog, it's less likely to get tricked.
It can still tell it's a cat, even with the costume.
Exactly, because the margin gives it that extra buffer.
Okay, I get it. So hinge loss is all about making that margin as big as possible.
You got it.
And that makes the model more robust and reliable.
Exactly.
But I have a feeling things aren't always so simple in the real world, are they?
You're right about that real-world data. It can be messy. It's rarely perfectly separable, like you said, with the cats and dogs.
Right.
There's always going to be some overlap, some ambiguity.
So like a picture that's kind of blurry.
Yeah, or maybe you have a picture of a dog, but it's mostly hidden behind a bush and you can only see its tail. It's still a dog. But it might be tough for the model to be totally sure.
So what happens then? I mean, how does hinge loss deal with those cases where it's not so clear-cut?
Well, that's where the idea of hard margin versus soft margin SVMs comes in. Hard margin SVMs, they're kind of like the idealists. They think all data can be perfectly separated.
Like with a really clear line.
Yeah, and they try to find that line with the biggest margin possible. Soft margin SVMs, they know that sometimes you're going to have those tricky data points.
The ones that are close to the line.
Yeah, or even on the wrong side. They have this thing called a slack variable. Basically gives the model a little wiggle room.
So it's like saying to the model, it's okay, you don't have to be perfect on this one.
Exactly. It lets the model off the hook a little bit.
And how does hinge loss fit into all of this?
Hinge loss works with that slack variable to adjust the penalty for misclassifications.
So the penalty isn't always the same.
Right. It depends on how far off the point is.
So if a point is way off on the wrong side of the line, the penalty's bigger.
Exactly.
And if it's just a little bit off, the penalty's smaller.
Yep, you got it.
This is starting to make sense now, this whole interplay between hard margin and soft margin SVMs and how hinge loss kind of brings it all together. So we've talked about those advantages, right? Like how hinge loss helps create that robust margin. But are there other reasons why it's so popular?
Oh, definitely hinge loss. It has some other tricks up its sleeve.
Like what?
Well, one big one is that it's computationally efficient. Remember how we were saying that hinge loss is happy when a point is on the right side and far from the boundary?
It gets a zero penalty.
Exactly. In those cases, it doesn't even factor into the calculations.
So the algorithm can kind of ignore those points?
Basically, yeah. It can focus on the ones that are closer to the line.
Or on the wrong side.
Exactly the ones that need the most attention.
So it's kind of like hinge loss helps the SVM prioritize its work.
Yeah, that's a good way to think about it.
Focus on the tough cases and don't waste time on the easy ones.
And that can really speed things up.
Especially when you're dealing with those huge data sets you were talking about.
Absolutely. The bigger the data, the more important efficiency becomes.
Okay, so it sounds like hinge loss has a lot going for it.
It does.
But I'm guessing it's not perfect, right?
Well, no, algorithm is perfect.
Right?
Hinge loss, it does have some limitations.
Like what?
Well, one of the main ones is that it's really designed for binary classification. Like cats and dogs.
Okay, so if we threw in hamsters and goldfish, it wouldn't work as well.
It would get a lot more complicated. Yeah, you'd need to use some modifications.
So for multiple categories, hinge loss isn't the best choice.
Not in its basic form, at least.
What else?
Another thing to keep in mind is that hinge loss doesn't give you probabilities.
Probabilities.
Yeah, like some other loss functions It doesn't tell you how confident the model is in its classification.
So it just says cat or dog.
Pretty much, yeah. It doesn't say, I'm 90% sure this is a cat.
Right, it just says cat or dog, no percentages.
Exactly.
Okay, so that could be a drawback in some cases.
It depends on what you need the model to do.
Right, if you need those probabilities, you might have to use something else.
And there's also a bit of a technical limitation. It has to do with differentiability.
Differentiability.
Yeah, it's a bit of a mathy concept.
Okay, maybe we don't need to go too deep into that.
Yeah, we can skip the nitty-gritty details.
What does it all actually mean for someone who's not a, machine learning expert?
That's a great question. I think the main takeaway here is that hinge loss and the SVMs that it works with.
Right.
They represent a whole new way of thinking about classification.
How so?
Well, it's not just about finding any line that separates the data.
Right.
It's about finding the line that gives us the most confidence.
Not most confident.
Yeah, in our predictions. It's about building models that are, really robust and reliable.
And that can handle those messy real-world situations we were talking about.
Exactly.
So in a way, hinge loss is helping us build AI systems that are more like human experts.
Yeah, I like that analogy.
Yeah, they don't just make decisions. They can actually justify them.
With a high degree of certainty.
Right, and that seems really important, especially as we start to rely on AI more and more.
Absolutely, especially in critical areas like healthcare and finance.
Yeah, where those decisions really matter.
Exactly. You want to be sure that the AI is making the right call.
So to all our listeners out there, the next time you hear about, some AI doing something amazing.
Yeah.
Whether it's recommending a product or driving a car or, diagnosing a disease, just remember that hinge loss might be playing a part in that.
It might be working behind the scenes to make sure that decision is as accurate as possible.
It's a fascinating world out there.
It really is.
And we encourage you to explore it.
There's so much to learn.
Well, thank you for joining us on this deep dive into hinge loss.
Yeah, it was a lot of fun.
And until next time, keep those AI curiosity gears turning.